All right, ladies and gents, so what we're going to be doing in this lecture video is looking at the types of motion that you can have at a synovial joint. So again, it's kind of like types of synovial joints, so what are they structurally going to be looking like? Again, this is just kind of an overall description, and there are plenty of opportunities and places where you can look to see kind of a structural picture or diagrammatic view of these. Okay, but what I really want to talk about here is just kind of the types of motion that you can see at each of these joints and what's structurally separating them from each other. Okay? All right, so our first type that we're going to be looking at in terms of structural classification is looking at a gliding joint. Okay. So a gliding joint is going to be one where it's going to be flat, or you're going to have slightly curved surfaces that are going to kind of roll on top of each other, okay, or slide across each other. So with these types of joints that are gliding, the amount of movement is extremely slight. We're talking like tiny little bits of motion. And by talking about tiny little bits of motion here, we're actually going to have instances where a little bit of motion will start to compound, right? And you'll get kind of a larger overall area of motion. Okay, so the examples of places where you might see these would be like in your clavicle. So between your clavicle and your manubrium, that's an example of a gliding point, right? Where that that sternal end of your clavicle kind of sits on top of that clavicular groove, right? That area there at the top of the manubrium, that's rolling over it. Your carpals, so part of your carpals and your wrists and your tarsals are gliding, right? Slight movements over on top of each other, but there is another type of motion that is there. You have your tarsals, again, sort of like your carpals, and then in your vertebra, you've got slight examples of gliding motion, like what's happening in your neck, as well as what's happening at all of the vertebrae as you go down. So again, gliding joints generally are going to be kind of stronger joints in the sense that they don't have as big a range of motion. But again, these joints are going to be overall, again, between flat and curved surfaces. All right, our next type of joint is called a hinge joint. Okay, so a hinge joint is a joint that allows or permits angular motion. So the idea of angular motion is where you're increasing or decreasing the angle between two bones. Okay, so this is going to permit motion on a single plane, so sort of like a door, right? A door can only open and close in a particular direction, right? With a hinge joint, right, these are joints that permit that angular motion again in one direction. So generally with a hinge joint, there is a point where the motion maxes out, where the hinge is no longer able to allow the bones to move, to either increase or decrease the angle. Okay, and this is maxed out either where the bones kind of hit their limit in terms of them rubbing next to each other, or the ligaments have stretched to their maximum. Okay. With your hinge joint, there's lots of different locations for those, right? Probably the most common one that you'll think of is at your elbow, right? Your elbow is an example of a hinge joint. As you say, take and flex, like flex them biceps because you're ripped. All right, those things, right? The idea there is that you're decreasing the motion between your radius and ulna and your humerus, right? And by doing that, you end up flexing the muscles there, right? But again, that's a motion that's only permitted on that single plane. You can't really rotate your elbow left and right out, and if you do, it hurts because you're going outside of the range of that synovial joint. Another example that I can easily show you here is like what's happening with your fingers, right? If you take your finger and you increase or decrease the motion between each of your individual phalanges, that's an example of a hinge joint, right? I can't take my finger and this part's up here, right, and make the move left and right. I can only make the move in one particular direction, right? And there's a limit. I can't really extend these back further than what the hinge joint's allowing me to do. Okay. All right. So fingers, toes, elbow, knee. Those are all examples of hinge joints. Okay. The next type of joint is called a pivot joint. So pivot joints allow for rotational motion. Again, the idea that you can turn and look left and right, all right, along a particular axis. Okay, so pivot joints, you don't have a whole lot of those in your body, but probably the most famous one is the one in your neck, right? As you're flexing your sternocleidomastoid on either side, right, decreasing the size of that one, you're turning your head left or right. And those are examples of where you're experiencing some kind of pivot, right, rotation, again, along a particular axis. The other one that's here is with your radius and ulna. So again, if you lift your radius and ulna out as you're going from supine to prone, right, you're going to have flexion at kind of this upper part. And just see my hair on. It's not really helping, but you're going to have this rotation or movement, and you can feel that if you put your hand on your elbow, right, and you actually allow for that there, you can feel the motion or the flexion that's occurring, or the rotation technically that's happening there because of the movements of like your pronator teres, your brachioradialis, again, the movement of the muscles there and allowing that pronation, supination motion as we're going like from palm up to palm down. Okay. Ellipsoidal joints, okay, these are just like crazy in that they are kind of oval in articular surface, right? They're kind of like that, and they're also sitting in a depression with other bones. So probably the most famous example of this is like what's happening actually like at this part of your finger. Okay, so like you can waggle your finger left and right, you can move it up and down. You can't make a perfect circle. Again, the reason why it's called ellipsoidal is that if you take your finger, right, and you draw or try to draw a circle with it, like on a piece of paper, like if I try to do that on a piece of paper, you can't make a perfect circle. It's only going to end up making an oval. Okay, and that's because you can only move along two planes. You can only move left or right or up or down. You can't kind of get those directional points in the middle. Okay, so it's sort of like if you're playing a video game console, you got the D-pad, like up, down, left, right. You don't have a joystick that allows you to go in all the directions. Okay, so with these particular examples, your radius and carpal, so again, what's happening between this part here and your carpal bones that are here, again, that's going to be ellipsoidal motion. Again, I can make my wrist go left and right. I can make it go up and down. But if I try to make a circle with it, it's not a perfectly smooth circle. Okay. What happens with your metacarpals in your fingers, again, that's an example where you have ellipsoidal. It's not going to be able to make a perfect circle. Okay. Our next type is a saddle joint. And this is where the articular surfaces fit like a rider in a saddle. So the idea that you've got kind of like these two sides fitting on this thing that allows you to move. Really the best example of that is what's happening with your thumb. This is one that is just kind of hard to think about and hard to see, but if you're thinking of your thumb, right, and the joint that's happening here, your thumb is kind of sitting on top of this articulation point that's like indented. So your the first part of your thumb here is kind of sitting inside of that. So again, you're allowed to do kind of a large range of motion. Your thumb can do quite a bit, maybe slightly larger than what's happening in your ellipsoidal. However, you still can't do a perfect circle with your thumb. Okay. So again, each face is facing the axis there. Just know that your thumb, your big toe, those are examples of where you're going to have some kind of saddle joint. And then our last type of joint, again, the ones that gives us the biggest range of motion, is a ball and socket. Okay, so in this is that there's a round head of one bone that inserts into a cup-shaped depression on the other. Probably the two best examples of this is going to be what's happening in your shoulder, right? What's happening between your humerus and your glenoid cavity inside of your scapula, or what's happening at your hip with the head of the femur hitting into your acetabulum. Again, those are where you've got this round, smooth projection that's allowed to move around, and you're able to get a full range of motion. So with ball and socket joints, these are the joints that allow you to do kind of a full circumduction. The idea that with those you can draw a perfect circle with those, as opposed to kind of a more ellipsoid shape that you would get with other types of motion. Okay. So those are the main types of synovial joints, and all of them, again, structurally relate to some particular type of motion. All right. In your next video, what you're going to be looking at are me going through and talking about the different types of motion overall. Okay. All right. So if you've got questions, let me know.